And evaluating a problem like this, 5 minus 5 gives us a 0 in the denominator. 5 squared is 25, minus 5 is 20, minus 30. That's not going to give us anything. That's not going to give us a problem, is it? So let's write that down to be sure we did that right. 5 squared is 25 minus 5 minus 30 over 5 minus 5. That gives us a 0 in the denominator. 25 minus 5 is 20 minus 30 is negative 10. Is this the indeterminate form? No. What does the indeterminate form look like? It looks like 0 over 0. So if you go back and look at the first slide, this is not indeterminate form. Then the answer here is either infinity or negative infinity. And we'll talk about how to do that later on. But for right now, know that this is one of these two solutions. We don't know which one. And before we have any formal assessments, we'll be able to determine which one it is. So it would either be infinity or negative infinity, but one of those two. But I put this problem here purposely because when you first look at this, you see x minus 5 in the denominator. You think, oh, I can factor this up here as x minus 5, x plus 6, and things will cancel out. But the numerator won't factor like that. So this problem would either be infinity or negative infinity for a solution in that. And this problem, when you look at this problem, it looks like, what on earth do I do with it? If I put in 9 minus 9, I get a 0 in the denominator. Square root of 9, 3 minus 3 is 0 in the numerator. Well, you've got a couple of options here. Any options that jump to mind here? Probably the most obvious thing for us, hopefully, is rationalizing the numerator. So if we multiply the numerator by the square root of x plus 3 over the square root of x plus 3, how did I get this name for 1? I'm looking at my numerator, and I'm looking at the opposite sign here. So it's the same thing, opposite the same thing. Now if we go ahead and evaluate this, we get in the numerator the square root of x times the square root of x is x. The inside and the outside cancel out. Minus 9. Well, that looks good because we've already got an x minus 9 in the denominator. So thinking ahead, we know that those two will cancel. And we're left with the square root of x plus 3. So now we know from prior experience this is going to cancel out, this is going to cancel out, and we can evaluate this and get the number 1 over the square root of 9 plus 3. Square root of 9 is 3, so we get a final answer of 1/6. And one final problem to look at here, next to final problem to look at here. What do we do with a situation like this? Again, if we plug in, we get 0 over 0. This is called complex fractions. So how do we evaluate when we've got complex fractions? We've got fractions over fractions. All right? There's a couple of different techniques. I think the easiest thing to do is let's look at our denominators. And we've got an x and we've got a 4 in our denominators. So what I want us to do is we want to multiply this by a special name for 1, and we're going to multiply it by 4x over 4x. Now, why did I choose 4x over 4x? Because that's my denominator. That would be my common denominator. So if I do this, in my numerator, I'm going to get the limit as x approaches 4 of 4x times x minus 4. I'm not going to do any more than that right now. What's going to happen when I multiply 4x times 1 over x? In that case here, let's write it out in a different color here. If I multiply by 4x here, then the x's will cancel out, and I'll just have 4 times 1, I'll just have the number 4 there. And the same thing if I multiply over here by 4x, the 4's are going to cancel out, and I just get x. So I've got this simplified. I don't have complex fractions anymore. Well, if I plug in, I still get 0 over 0. So I've still got some work to do. But what can I do now? Well, if I look at my two binomials, they're almost alike. I've got x minus 4 and 4 minus x. So what could we do to make them identical to one another? I'm going to take the bottom one and factor a negative 1 out. And you may ask, why would we want to do that? Well, if you remember when we talked about factoring, we talked about anytime the highest exponent is preceded by a minus sign, we want to factor out a negative. So the highest exponent is 1. We're factoring out a negative, and if we do that, that makes the x positive, so I'll write it up front. That makes the 4 negative, I'll write it here. And now suddenly, our two binomials are the same. So now we can get rid of them. So we've now reached out and found out that the limit as x approaches 4 is 4x over negative 1. Well, we've got a number in the denominator, so we know it can be evaluated. 4 times 4 is 16, so we get a final answer of negative 16 out. And now one final problem to look at. The square root of x minus 1 minus 4 over x minus 5. Again, initially look to plug in. 5 minus 5, 0. That would give us 5 minus 1, which is 4. Square root of 4 is 2. 2 minus 4 is not 0. So that tells us that this is not going to be an indeterminate form. Let's plug this in again and just verify what we did in our head. We get the square root of 5 minus 1 minus 4 over 5 minus 5. And if we do that, the square root of 5 minus 1 is 4 minus, is the square root of 4, minus 4 over 0. But the square root of 4 is 2 minus 4 over 0. So we wind up with negative 2 over 0. So what's our answer? Again, going back and look, our answer is either infinity or it's negative infinity. And later on we'll explain what that means better. But for right now, just understand, if you come up with a number over 0, then the answer is either infinity or negative infinity, and we'll determine which one at a later date. So we've gone through several different problems now, many different techniques on how to evaluate these. So the main rules for you to remember here is the first thing you always want to do is plug in. Once you plug in a number, you'll either get 0 over 0, and if you get 0 over 0, that means you're going to simplify it some way. Simplify could mean factoring, could mean canceling, could mean using trig identities, could be rationalizing, but you're going to do something. Or you're going to get a number. That means that the limit is that number. Or you're going to get a number over 0. And in that case, we know that the limit is either infinity or it's negative infinity. Okay? So those are the three things for you to remember. You start off by plugging in to determine what you need to do next.